Good evening, dear students of medicine everywhere, and especially my own students. Today we are going to talk about the anatomy and physiology of the vitreous humor. What is vitreous humor? Vitreous humor is a colorless, transparent, and gel-like substance that fill up the posterior cavity of the eye. The word vitreous is the adjective form of the word vitrium, which means in Latin language glass. This means that the vitreous humor is actually a glass-like humor or a glass-like body which is colorless and transparent and allow the transmission of light toward the retina of the eye. Okay, the vitreous humor has a small weight relatively. It is about 40 grams only. Its volume is about 4 cc, but this little volume actually forms 4/5 of the overall volume of the eyeball. The vitreous humor is found, as I mentioned, the posterior cavity, which means between the lens and the retina. But it has a spherical form, as you see, but has a depression in the anterior segment of the vitreous. This depression is due to the retrolental space, which is found behind the lens, the crystalline lens, and anterior to the vitreous humor itself, and it is actually filled with the aqueous humor, which is found in the anterior cavity of the eye in its two parts, the posterior chamber, which is found between the iris and the lens, and the anterior chamber, which is found between the iris and the cornea. Okay, what is the content of this gel-like substance called vitreous humor? About 99 to 99.7% of the vitreous humor is composed of water, and the remaining part has different contents or different compositions. First of all, it has proteins and collagen fibers and electrolytes and glucose. As a summary, the water, as I mentioned, form about 99%. The collagen fibers, we have two types of collagen. The largest part is collagen type 2, which forms about 90% of the overall collagen in the vitreous humor, and collagen type 9, which forms only 10%. There is also hyaluronic acid and soluble proteins. The soluble proteins amount is very small compared to the proteins in the plasma. It is only about 10% of the plasma concentration of proteins. This allows the light to be transmitted without any impairment. Okay, the vitreous humor has different anatomical landmarks. There is a condensation of the vitreous material in the anterior part of the vitreous humor that is called the anterior limitant membrane. I mean this part, from the ora serrata, which is the anterior part of the retina, and behind or posterior to the crystalline lens, to the other side of the eyeball wall. And the other condensation in the posterior part of the eye is called the posterior limitant membrane. I mean this thing. So we have the anterior limitant membrane and posterior limitant membrane. But those membranes are not actual membrane. They are condensation of the hyaline and the matter that form or compose the vitreous humor itself. And the outermost part of the vitreous humor is called the vitreous humor cortex. It forms about 2% of the overall body of the vitreous humor. And the remaining part, which forms most of the vitreous humor, is called the cortex. Cortex is in structure is similar to the vitreous humor. Sorry, the outer most layer is called the cortex, and the remaining part is called the medulla. The medulla is similar to the cortex, but with less fibrillary structure and more fluid. So once again, the outer layer, which also involves the anterior and posterior limited membrane, is called the cortex, and is with most or more fibrillary structure, more collagen fibers, I mean, and the remaining part has a lesser fibrillary structure. There are also what is known as tract. This is also condensation of the vitreous human material. We have the pre-rental tract. They are actually about 4 tracts in each side of the vitreous humor. There is the pre-rental tract here and here, and the retrolental tract. There are also chordal tracts, but they are small ones. The tracts actually divide the vitreous humor into 3 major zones: the pre-rental zone here and here, and the intermediate zone also here and here, and in the center there is the retrolental zone. As you see, this canal in the middle of the vitreous humor is called hyaloid canal, or sometimes it's called also retrolental canal. It is not an actual canal, but in its site during the embryological development there was what is known as the hyaloid artery, which will be vanished after the embryological development has advanced, and during the embryological life there is what is known the primary vitreous, which will then develop into the adult vitreous humor, which remains in our eyes till our death, since our birth till our death, without any change or without any decreasing. Okay. This is, in general lines, the most important anatomical features related to the vitreous humor. Talking about the electrolytes in the vitreous humor, there are less cations and more anions, I mean more chloride and more phosphate compared to the plasma. There is also glucose and glycogen in the retina. The glucose in the retina actually of benefit for, the glucose in the vitreous humor is actually has benefits for the retina, especially in the anoxic situation. When there is decreased oxygenation of the retina, it may gain energy from the glucose that is found in the vitreous humor. The vitreous humor is with very little communication with the surrounding structure of the eye, because there are a lot of barriers, such as the blood retinal barrier and the barrier which is formed by the non-pigmented cells of the ciliary body, because there are plenty of tight junction between those cells, as well as is true for the retina and the pigment epithelium of the retina. Okay, now the question is how the vitreous humor is keeping in place in the posterior cavity. Actually, there are a lot of ligaments that connect the vitreous humor to the surrounding structures inside the eye. One of the strongest ligament is called the vitreous base, which connect the vitreous humor to the ciliary body and to the region or area of ora serrata, which is the most anterior part of the retina. This part of the retina, the most anterior one, is called ora serrata. This is the vitreous space, which is a ligament that attaches the vitreous humor to the ciliary body and to the ora serrata. And this one, which is also called the retrolingual ligament, that connect or attach the lens, the posterior pole of the lens, to the vitreous humor. And there is a ligament that attaches the vitreous humor to the macula of the retina, in addition to other weaker ligaments that connect to the vitreous humor to the central parts of the retina. Here I have to underline an important clinical fact that with aging, this vitreous space and of course other ligaments may get more flexible posteriorly and anteriorly, and this may assist in the attachment of the vitreous humor from the retina, that we will talk about it soon. Okay, due to the presence of plasma proteins and of phosphate and chloride, which have a buffering capacity, we can notice that the pH of the vitreous humor is slightly alkaline. It is from 7.4, which is similar to the plasma, to 7.52, which is I want to underline the fact that the decreased amount of soluble proteins in the vitreous humor compared to the plasma is quite beneficial, because it prevents the scattering of light when it penetrates the vitreous humor. Here also I would like to remind that there is a refractive index, which means the speed by which the light enters any medium. The refractive index of the vitreous humor is about 1.336. Now let's go back to the physiological part of our lecture about the physiology of the vitreous humor. I mentioned the most important, or two of most important functions of the vitreous humor, which is filling of the posterior cavity of the eyeball, which maintain the shape of the eye, or in other words, inflating of the eye to allow the light to be transmitted toward the retina. But there are also other functions, such as the metabolic buffer function. Metabolic buffer, especially due to the proximity or neighboring of the or with the ciliary body, this will keep something like metabolic barrier with the ciliary body, and also with the retina. With the retina, it also forms what is known as diffusion barrier. Most of substances that are found in the anterior cavity of the eye, I mean the aqueous humor, and some of the topical drugs cannot penetrate the vitreous humor and thus cannot reach the retina because of the presence of the vitreous humor that prevent the diffusion of substances from the anterior cavity of the eye, or from the blood vessels that supply the retina. And it is also, as mentioned, a bath of light. But there is also a good function, or an important function, for the vitreous humor, which is anti-angiogenesis, because the vitreous humor has no blood vessels. It has a lot of factors that are anti-angiogenic, which means that they prevent formation of blood vessels inside the vitreous humor, such as the neutrophil elastase inhibitors and the thrombospondin factors, and others, of course. These factors actually prevent the angiogenesis, or formation of new blood vessels inside the vitreous humor. This is quite important to keep the vitreous humor transparent and allow transmission of light toward the retina. One of the composition of the vitreous humor is the cell, but cells inside the vitreous humor are with very little amount and mostly are the phagocyte cells are group of cells which phagocytoses the debris or any foreign materials that can penetrate into the vitreous humor as a result of trauma or as inflammation. The other type of cell is the hyalinocytes. Okay, this is almost everything about the anatomy and physiology of the vitreous humor, but we have to notice two things or two clinical applications related to the vitreous humor. With aging or as a result of trauma or inflammatory process, sometimes there would be a detachment of the vitreous humor away from the retina. This is dangerous for the retina because it would not be kept in place and may be vulnerable for further trauma or further lesions. Another thing, which is the synersis. Synersis means the liquefying of the vitreous humor, become more liquefied. This will cause coagulation of some of the proteins that will cause what is known as floaters that can be seen in the visual field of the human visual field of the human organism. Thank you very much for being with this.